Hi guys, another riveting video on DC cables. We're not going to talk about cable calculations though. Cable calculations we're going to leave alone for a separate time. These are not the calculations you are looking for. We're going to talk about the standards and requirements of DC cabling in a solar installation. It can be something that's run past really fast by electricians of, oh, it's what I've got in the van, it's what's available to me. Hopefully it's not the cheapest at the time. There's so many different types out there at the minute. There's so many different flexibilities. There's so much cable, what the cable compound's made out of. There's so many different ways that the cables have been made up. So one of the things that we need to check on these is obviously cable calculations. Are we using 6? Are we using 4? Are we going even bigger? Are we using a combiner box on the roof? But then after that is, can that cable take that voltage that you're putting down it? When you've done your string calculation, oh, I know I'm going to have 780 volts down that cable. You should be able to take 1,500. I'd be aiming for, and in most installations, actually just be safe. Just get the best cable you can afford. That's the short end of it. But yeah, we're checking the voltage. Can it take it? We're checking the current. Can it take it? Remember, our current goes up and down, so it's not always the same. So what level of current should we be designing for? That's something to think about and something to challenge your thinking of. Most of the time, it's going to be taking the maximum current down it. So do we want a low resistance, slightly bigger cable? You do the maths, look at what you're losing if you put in smaller cable when you're designing it. Compare it to the cost difference. If you're doing a cost benefit analysis of 6mm versus 4mm, be very interested to talk to some of you guys that do the solar farms and see what your cost benefit analysis of using slightly larger cable. The other thing is, can it take the temperature that it's going to be going in? Sometimes these are in containment, sometimes installers leave them open in the fresh air. So which brings me to the next one, the UV ratings of them. And we obviously want to try and protect these cables as much as we can when we're bringing them into the buildings. Penetration is another thing that we're going to look at in a later video. I've worked out about 5 or 6 different ways of getting cables into a building. I know there's endless ways. There's probably about 2 or 3 that I really prefer, and we'll go into that with some photos and bits and bobs. The other thing is checking the standards that cable's been manufactured to. So there's some really good MCS documents on this. I'll put a link in the description, and there's also an IET document on DC cables as well. I'll put a link to that in the description. That's Justin, just explaining a little bit more about DC cables in the solar industry. I hope that's been beneficial. If you've had any struggles or you found anything really useful tips for DC cabling in solar inverters, please comment, please DM me, please reach out and let me know that you found a brilliant cable for our solar world that we're all working in. I just hope I'm bringing some more help and understanding to people in the solar industry. That's JustinDring from Independent Solar Consultants, hoping to help and bring light to more places in the solar industry.